Okay, we're going to go ahead and get this exercise started. So you should have watched the setup and you should understand the basic idea here of this compound proposition. We're going to be doing a series of replacements, just replacing one compound proposition with an equivalent compound proposition. And it's hard to know where to go, where to start, but you got to start somewhere, you got to try. You got to throw away a bunch of pieces of paper and scribble things out and break pencils, and you might get frustrated. It's okay. Just take your time, take a deep breath. Don't try to do 10 of these in one day. Just start one, see if you can do it, okay? Give yourself time to do this. So, thinking about this compound proposition, I want to build it so that there's all ands and ors and nots. Because I know if I do that, if I look at my key logical equivalences that have true in them, which is where eventually I want to go, are here with my negation laws. P or not P is true, and P or true is true. So I want to think about these and do a bunch of replacements. And what I notice is I have a lot of implications going on. So most likely what I'm going to want to do is take all my implications and replace them with this material implication, okay? Or in those videos that you watched, he refers to it as material implication, so we could do that replacement. All right, so let's get started here. We're going to have to keep order of precedence in mind. I know that because of order of precedence, I'm going to have to start out by completing this first before this implication. I know that this and comes before the implication in the order of precedence. So it's like there's an implied, so I'm going to work on the left-hand side to start. Well, sorry, I'm a creature of habit, but what I'm thinking in my head, what I'm trying to prove, generally you've got two sides of your logical equivalence you're trying to prove, and the two sides in this case would be, I'm running into this guy here, is logically equivalent to true. Okay? So it's like in my head I think, oh, left-hand side. Okay. So I'm going to go ahead and copy that down just so I know where I'm starting. So I've got P implies Q, and Q implies R, implies P implies R. Okay. So my justification here is just my starting point. Okay. Alright. And then I'm going to say, okay, I know that this is logically equivalent to the grouping of that and operation, because I know with order of precedence the and operation comes before the implication. So I want to be sure to, oh, maybe I don't want to use that symbol. I'll use bullets. Order of precedence. The and operator comes before the implication operator, so I know that I want to group that. Okay, so let's take a look at what we've got to work with. I've got a lot of implications going on, okay? And eventually I'm going to want to replace all of them with that logical equivalence. This is actually what I'm going to use in the steps, so I'll go ahead and write it here. But I know that P implies Q is logically equivalent to not P or Q. So eventually I'm going to want to replace all of the implications with that alternative form there, with the not and the or. But so I'm just going to go ahead and show you the first step here, and there is a lot of ways to approach this. So don't think that because I'm doing this step first, you have to do this step first. Okay. As long as you follow the order of precedence, and also you actually supplement or replace with logically equivalent things. Okay, got to do both of those things, otherwise your steps will be incorrect. But so what I'm going to do first is take care of this implication here. And I'm going to use this logical equivalence. And the way I read this logical equivalence instead of with P's and Q's, because notice we've got P's and Q's and R's here. So it's a little bit confusing because like here, for instance, this Q implies R, that doesn't have the same spot as Q, and sometimes it drives people mad, okay? The way that I read this is a hypothesis implies conclusion is logically equivalent and this is the point that I use all the time when I'm changing implications to this other form here. So this part is logically equivalent to the negation of hypothesis or conclusion. So instead of thinking about P's and Q's, that's going to drive you mad, I'm going to think about hypothesis conclusion. Okay. So in this case, this whole thing is my hypothesis. And this piece here is my conclusion. Okay? So thinking about the negation of the hypothesis or conclusion here and using this logical equivalence, okay? What I'm going to do is replace this implication with an or, but then I also need to negate the hypothesis if I do that. So negation, now careful, you're negating that whole thing in that first thing, okay? Got to be careful. If you don't, you're going to have something goofy there. And Q implies R or conclusion. Okay, so see how I have negation. Let's see here. I have negation of my hypothesis or conclusion. Okay, so negation of hypothesis or conclusion. All right, now we're getting somewhere. Look, I only have 1, 2, 3 implications now, so it seems like we are on the right path here. All right, now I still have implications going on. I don't like those. But the other thing I notice is that I've got this negation that's just asking to be distributed so I can get everything on the same level. Because eventually I'm going to want to combine P's with P's and Q's with Q's and P's with not Q's and P's with not P's and Q's with not Q's, right? But I can't do that because that negation is preventing it. It's almost like, let me go to this little scratch page here. It's almost like if I had negation of 3 plus 5 plus 8. I want to combine these guys. I want to combine this and this, but this negation here is causing issues, okay? So I can distribute it, okay, or I can just say 3 plus 5 is 8. Negative 8 plus 8 is 0. Maybe a better example, let's suppose it was like negative 2 times 3 plus 5. In order to combine that with 8, I need to take care of this multiplication operation here, okay? Sometimes it helps to think about that. Sometimes it doesn't. So, all right, so what I'm going to do is use Demorgan's laws. Okay? This was in one of the videos that you should have watched from William Spaniel, right? That Game Theory 101 guy. And so Demorgan's law, and notice we've got an and. So Demorgan's, we're starting with an and. If we negate P and Q, we get the negation of P or negation of Q. Okay? And again, careful with your P's and Q's. Just think about it. And this isn't quite right because with order of the and operator is commutative, okay? So it's kind of weird to say first proposition, second proposition, but maybe if that helps to think about it. We can say negation of these two propositions is the negation of the first proposition or negation of the second proposition. So this negation only applies to this piece, right? So I'm going to go ahead and apply that negation idea here with Demorgan's laws. So I've got negation of my first proposition, or notice that logical connective switches, and hopefully if you watch that video that makes sense why it switches. Because that's something that boggles you, you know, until you get to a certain point. Hey, why aren't you working with me? Negation of Q implies R. Now, this is looking better already, and let me tell you why I'm excited. I have three little pieces, right? Three little pieces, and they're all with an OR operator. That's awesome, okay? Because now I can do these in any order I want because OR is a commutative operation, okay? And I can't really do that yet because I've got these implications here and they're causing havoc for us, okay? Now, there's a couple other options here at this point. Again, we're just trying to get down to ands and ors, okay? We might have some clever implication equivalences to deal with here with the negation of these equivalences, or the negation of these implications. So let's take a look and see what's going on here. Let's look at our logical equivalences involving conditionals. So notice the negation of an implication is P and not Q. Okay. And let me just do a nice little proof of that here, okay? The negation of implication. I know that implication can be the negation of the hypothesis or the conclusion, so I'll do that implication first. Then I'll apply Demorgan's negation of the first one, switch the operator, so we've changed it to an or, negation of the second. Double negation rule, if I negate a negative, I just get back to the original. So wham bam, right? We just showed that that's true. So let's go ahead and use it. And you're not going to have to show it every time. I just wanted to show it so that you believe that it's true. Okay. Another kind of like side note here, a lot of times people get a little clever, and the logical equivalence that I'm trying to ask you to show is given in the table. Okay. If I'm asking you to show it, you can assume you can't use the table. Okay. You can use the table, the other logical equivalences in the table, but you can't just say, oh, this logical equivalence is listed on the table, done, right? Okay, and I'll try to be careful with that and say, hey, this is in the table, but you can use all the other equivalences but that one, okay? All right, so let's go ahead and take care of this negation. What I'm going to do is I'm going to use that logical equivalence that we just found out about. We said the negation of P implies Q, and we just proved this, right? So we really believe it. P and not Q. Okay, so again, think about hypothesis conclusion. Okay, think this is the negation of hypothesis implies conclusion. That's logically equivalent to hypothesis and negation of conclusion. Okay, so we've got these two guys here that are negating implication. So I'm going to go ahead and take care of both of those. All right, so if I negate P implies Q, P is my hypothesis, Q is my conclusion, so I'm going to have, and I'm going to go ahead and group this so I know what's going on here, okay? So I'm going to group it. I've got P and not Q, or hypothesis and not conclusion. Or then I'm going to negate this middle one. So I'm going to think hypothesis is Q, hypothesis and not conclusion, conclusion is R. And I'm gonna go ahead and just leave P implies R for now. We're gonna take care of it on the next step. So we're getting closer, right? Now we only have one logical connective that's not an and an or not. And that's good because we'll be able to use those ideas with truths, what tautologies that we know to break it down eventually to T. Okay, true. So let's see what we got here. I'm going to go ahead and replace and get rid of that final implication. And just so that we're clear on what I'm using here, I'll use that logical equivalence. P implies Q is logically equivalent to the negation of the hypothesis or the conclusion. So that's what I'm going to use here with the P implies R. So I'm just going to write that right here so that we're sure how we got that. I'm going to do everything else in black. And guys, your homework's not going to look like this at all, right? This is kind of a disaster because I'm writing a lot of notes and extra stuff. So really, all you should have on your homework is all of the black, right? Each of the steps that we're taking, and then the justification for each step. So the justification, now make sure you draw a line so that I know what's what, but just go ahead and list the logical equivalents that you're using. You don't have to worry about the laws and the fancy names because those can get, ugh. Just write down the implication that you're using here, okay? And there's examples of this so that you understand what I'm expecting, okay, hopefully. All right, so now let's see what's going on.